We're excited to announce IBM PowerHA with multi-target geographic mirroring. Before we jump into this exciting announcement, let's revisit what geographic mirroring is. I have our IBM, the operating system we know and love, and this IBM is of course running on physical hardware somewhere. It might be in our data center or it might be in the cloud. This system has main memory and this system has disk units. During the course of operation of the system, at some point data in main memory will be written to disk and the disk units will acknowledge that data has been written and the system can continue. One of the things that we know is that our system knows how to bring disk units online after you power off the system. So PowerHA relies on this idea of replicating contents on disk to another location. I'm going to call this system our production system. And I'm going to have a second system called HA that also has physical hardware, memory, and disk. There's a TCP/IP network between these two systems. And with geographic mirroring, as data gets written to disk, that same code in the OS that is going to send data across our TCP/IP network to our HA system to be written to disk. Our HA system will of course acknowledge this along with our production system and things can continue. We now have identical copies of data on disk. Geographic mirroring is what we call ISP replication using IBM networking. Some of the features of geographic mirroring. First is simplicity. Replication is done at the page level, not the object level. There is no concern about what objects are replicated or if an object is locked. If that object is in a library that's in the independent ASP, it will be replicated. In addition, management and control of geographic mirroring is nearly identical to other PowerHA technologies, such as MetroMirror or Global Mirror with IBM Flash System or IBM DS8000 storage. In addition, geographic mirroring is storage agnostic. This means that you can have different sizes or types of disk units between the two systems. They can be internal storage or external storage, and this enables it to work in cloud and hybrid cloud environments. We are introducing an exciting enhancement to geographic mirroring, multi-target geographic mirroring. Multi-target geographic mirroring extends the existing geographic mirroring capabilities to enable replication between up to 6 cluster nodes. This provides enhanced flexibility for the ability to maintain multiple copies of your data even during an outage of one of them, or the ability to protect your RPO during a save by offloading it to a separate node. Multi-target geographic mirroring provides enhanced flexibility even for complex environments. In this example, we have a data center in Minneapolis and a second data center in Dallas. These data centers are connected by a TCP/IP network. In Minneapolis, I have a production system, and I also have an HA system called MSP-HA. In addition, I perform backups at my production site, so I have MSP backup. The replication within the site is performed via synchronous geographic mirroring, meaning all 3 copies are identical. Synchronous replication does have distance limitations of typically around 10 to 30 kilometers depending on your latency tolerance. We can then introduce an asynchronous link to another location, in this case Dallas, where within our Dallas site we have Dallas HA1, and then synchronous replication within Dallas to Dallas HA2 and Dallas backup. PowerHA has automatic topology management where the topology automatically adjusts based on the ordering of available nodes, while optimizing traffic across your long-distance site to use a single link. So for example, in this case, Dallas HA1 failed. When that system failed, replication switches to run between MSP production and Dallas HA2, which then replicates to Dallas backup. Multi-target geographic mirroring also simplifies hardware upgrades in a geographic mirroring environment. Here, I have a simple 2-node geographic mirroring environment, and I'm ready to upgrade my production and HA systems from Power 9 to Power 10. Let's do that now. Notice how our users are currently accessing my production system. I'm going to add in a new HA node to my cluster called new HA and configure geographic mirroring to this new node. This can all happen without an impact to my users. Once replication is caught up, we can deconfigure replication to our old HA system and then remove our old HA system from the environment when we no longer need it. Our end users have not been interrupted during this process. We also maintained multiple copies of our data during this entire process. To upgrade our production system, we can bring in a new production on Power 10 and configure replication to that new production system and wait for it to complete. At this point, we're ready to take a small outage to perform a simple PowerHA switchover to our new production system using the Change Primary Node option in PowerHA. Once users are accessing our new production system, we can deconfigure replication to our old production system and then remove our old production system from our environment. During this entire process, we protected our recovery point objective and our recovery time objective. The only outage we took was to perform a single switchover from our old production to our new production. All of these enhancements will be available for IBM I PowerHA 7.5 via PTF in June of 2023.